400 feet beneath the freezing surface of the Sea of Okhotsk, in water claimed by the Soviet Union, a machine the size of a small truck sat motionless on the seabed. It carried no warheads. It launched no missiles. It never moved an inch after installation. Yet the Soviet High Command would later call it one of the most dangerous weapons America ever deployed against them. For nearly a decade, the silent device turned the ocean floor itself into a listening post. It recorded the unencrypted voices of Soviet submarine commanders, fleet admirals, and nuclear planners as they spoke across a cable they believed was invulnerable. Then one man sold its secret. Not for ideology, not for glory, for $35,000 and the chance to climb out of personal bankruptcy. What he betrayed was not a missile design or a code book. He betrayed an engineering solution so elegant, so audacious, that the Soviets had never imagined it possible. The question is not simply why a man sells his country. The question is what kind of machine is worth that price. By the late 1960s, the strategic balance had shifted underwater. Soviet nuclear submarines could launch ballistic missiles from the safety of the deep. Their commanders no longer needed to surface and expose themselves to radio interception. Instead, they spoke through hardened undersea cables that linked their Pacific Fleet bases, Petropavlovsk on the Kamchatka Peninsula to Vladivostok, and later Northern Fleet nodes. These cables carried voice, teletype, and command traffic. The Soviets considered them secure for a simple reason. At 120 meters, the pressure is 12 atmospheres. Seawater is an aggressive electrolyte. Any physical penetration of the cable sheath would short the conductors, trigger alarms, and leave forensic evidence. Radio signals could be intercepted. Satellite imagery could count ships. But a cable lying on the continental shelf inside Soviet territorial waters was, in the eyes of Soviet planners, beyond reach. American intelligence needed those conversations. The old methods had failed. Surface ships could not linger. Aircraft could not loiter. Conventional submarines lacked the endurance and the specialized diver systems required. Captain James F. Bradley of Naval Undersea Intelligence refused to accept the premise. Bradley's first insight was almost childishly simple. Growing up along the Mississippi, he had seen signs. Cable crossing, do not anchor. The Soviets, he reasoned, would post identical warnings for their own fishing fleets. In October 1971, the nuclear submarine USS Halibut, funded in part by diverted deep submergence rescue vehicle money and disguised with fake rescue vehicle on its deck, slipped into the Sea of Okhotsk. Within days, the crew spotted the Cyrillic signs on the shoreline. They found the cable. The depth was 400 feet. Conventional compressed air diving would kill a man through nitrogen narcosis or decompression sickness long before the work was finished. The solution was saturation diving with helium oxygen. Helium's lower molecular weight allows it to leave human tissue far more rapidly than nitrogen. Divers could remain at pressure for hours, live in a pressurized habitat on the submarine's deck, and return without fatal embolism. It was one of the earliest operational uses of the technique. Now came the harder problem. You could not cut the cable. Any breach allows seawater to reach the conductors. The resulting short circuit would be detectable at both ends. The Soviets would know immediately that something was wrong. The American solution was pure physics, electromagnetic induction. Current flowing through a conductor produces a magnetic field. That field exists outside the insulation. A carefully designed coil wrapped around the cable can sense the changing flux without ever touching the metal. The first device was relatively modest. A recording pod roughly 6 feet long, battery-powered, capable of capturing weeks of traffic. Divers clamped it in place. The pod was engineered to release and sink if the Soviets ever raised the cable for maintenance. The first tapes returned to Pearl Harbor and then to the National Security Agency revealed something almost unbelievable. The Soviets were so confident in the physical security of the cable that large portions of the traffic ran unencrypted. Fleet movements, submarine readiness, even personal conversations between officers and their families. The intelligence yield was extraordinary, but the raw signal was chaos. A single armored cable carried multiple multiplex channels. Voices overlapped, teletype and voice mixed. Separating them required on-the-fly engineering that remains partially classified to this day. Technicians jerry-rigged filters and channel separators until individual conversations emerged. Success demanded a more permanent installation. Bell Laboratories, already masters of undersea telephony, produced a next generation, a 6-ton monster known as the Beast, powered by a radioisotope thermoelectric generator that converted the heat of decaying plutonium into electricity. It could record a full year of multi-channel traffic without battery changes. Divers from Halibut and later from Parcha, Seawolf, and Richard B. Russell returned periodically to swap the massive tape reels. For nearly a decade, the ocean floor itself had become an American microphone. The engineering had solved the impossible: pressure, corrosion, detection, power, data volume, human physiology at depth. All of it had been conquered. Then the device vanished. Ronald William Pelton had spent 14 years inside the National Security Agency. He was fluent in Russian. He possessed an extraordinary memory. He had worked on signals intelligence projects that gave him detailed knowledge of the most sensitive collection systems America operated against the Soviet Union. By late 1979, he was financially ruined. He walked into the Soviet embassy and offered what he knew. No documents changed hands. Pelton carried the architecture in his head. The location of the Sea of Okhotsk cable, the inductive principle, the recording cycle, the submarine support requirements, the vulnerabilities. He was paid $5,000 specifically for the Ivy Bells information, and roughly $35,000 total over the following years for a broader set of disclosures. The Soviets did not act immediately. They studied. In 1981, American reconnaissance satellites photographed an unusual concentration of Soviet naval vessels, including a salvage ship, sitting directly above the coordinates of the tap. When the USS Parcha returned to service the device, the divers found nothing. The Beast was gone. Later it would appear in a Russian museum. Pelton's betrayal did not merely end one collection program. It demonstrated that the most sophisticated physical engineering advantage can be nullified by a single human decision made under financial pressure. The primary curiosity loop closes here. The machine worth betraying a nation for was an inductive, non-penetrating, nuclear-power recording system that turned an unbreakable Soviet cable into an open microphone for nearly a decade. Its value was measured not in explosive yield, but in strategic warning time, in the ability to hear the enemy's private planning, and in the quiet confirmation that the other side was less prepared than it claimed. Other taps continued elsewhere. One northern cable remained operational until the end of the Cold War. But the Okhotsk system, the original, the most daring, was finished. The engineering triumph had been perfect. The human element had not. Operation Ivy Bells proved that the most secure communications medium can be compromised by an adversary willing to solve the physics rather than cryptography. It forced a generation of military planners to reconsider what secure actually means when the environment itself can be instrumented. The same inductive and later optical principles evolved into modern undersea cable surveillance architecture that still shapes intelligence collection today. Yet the deeper lesson is colder. America spent years. Specialized submarines, saturation diving technology, nuclear power sources, and the quiet courage of divers working at the edge of human endurance to build a machine that could hear an enemy that believed itself silent. One former analyst, drowning in debt, sold a location and the method for less than the annual salary of a mid-level bureaucrat. In the end, Ronald Pelton did not steal a weapon. He did not steal blueprints for a missile. He stole an engineering advantage. The knowledge that the ocean floor could be turned into a sensor, that pressure and induction and human physiology could be mastered, and that an entire strategic conversation could be recorded without the speakers ever knowing. That advantage was worth more than any single platform, and it was lost not to superior Soviet technology, but to the oldest vulnerability in every complex system. The human being who understands it. The machine was perfect. The men who built it were not. If the engineering that decides a balance of power interests you, subscribe. New investigations every week.